Hi, my name is Robert Roscott, and today I'll be giving a short presentation showing how PaNOSC aims to implement FAIR principles and how this could help improve the stage of scientific data analysis at photon and neutron facilities. A common workflow nowadays is that scientists will find a paper that they're interested in, and then they might decide to play around with the data or the analysis on there or build on top of what has been done in that paper. The first step of actually doing this would be reproducing what's already existing, which is where the challenges start. So the first main challenge is finding the raw data and code that was used to create the results from the paper. Most often, these aren't explicitly mentioned or cited in papers, and you'll have to resort to directly contacting the author of the paper or the facility itself. If you do manage to get your hands on the code that was used to analyze the data, then there are a couple of other hurdles to pass. The first one being actually being able to install that code successfully. Quite often the requirements of code aren't well defined, so reproducing the analysis environment used to create a paper will be rather difficult. The second problem is even if you do manage to create a software environment identical to the one used to make the paper, then actually running that can be challenging due to high computational requirements. And this problem will only increase as the volume of data and the complexity of analysis increases over time. The other issue is getting access to the data itself. Facilities might not actually have an egress policy in place for what to do if they're requested to send data to an interested party, or they might not have the infrastructure in place to deal with transferring large volumes of data. And even if that is in place, then it's quite likely that you, as a researcher or a scientist, might not have the facilities in place where you work to actually store the data that you would need to store to be able to reproduce the results of a paper. So in summary, currently there's quite a lot of hurdles to get past. So there's getting the code and being able to run it, and then getting the data, being able to store it, and having the infrastructure in place to be able to do all of these things. This makes it rather difficult for reviewers to do their jobs and makes it quite hard for scientists to collaborate as well, which leads to a lot of wasted time and effort by scientists having to recreate analysis that has already been done and already been written by others. So PaNOSC aims to help streamline this process a bit. So the scenario starts the same, with the scientists finding a paper that they're interested in. But now on the publication page, there could be an additional button. So as a small mockup, there could be a launch with PaNOSC or launch with EOSC button embedded in the journal page or in the DOI page. Now, clicking that badge would bring you to a single sign-on solution, like it's provided by EGI or Umbrella. From here, the scientists can enter their facility and log in with their account. If their facility isn't on the list, then they're also able to log in with commonly used accounts like GitHub, Google, or LinkedIn. From here, you are put into an interactive analysis environment powered by Jupyter where you're allowed to explore the data and code. You don't have to worry about how to install the software or how to get the data, as these environments would run at the facility where the data was originally collected and where the analysis was originally performed. The first page you would see in these notebooks would be a README page, which has links to all of the relevant notebooks contained in this analysis environment, and also has some other useful links like those to the paper itself, to the journal, and the abstract, as well as the authors list. From here, you can just run through the linked notebooks to recreate the results that were cited in the paper, or you can alternatively play around with the code, change what happens. So as a short example, this is a small snippet from the paper used to create this example. This is figure 6, where you can see just some relatively simple scatter plots. And then in the linked notebook, we reproduce those plots exactly and also work out the slopes and fit this data again. So from here, the scientists could go through and change the axes or change the amount of data that's being plotted or try to fit some other curves to it and expand on the analysis. This example was specifically curated for this presentation. So currently this still runs on binary services as the infrastructure isn't set up yet to allow other external users to use our facility's resources, but it illustrates the ways that PaNOSC could help bring fair to the photon and neutron community. This demo is available online. If you go to this URL, it will take you to the GitHub repository that contains all of the data required to set up the environment as well as the notebooks, which reproduce the results in the paper. You can then click the Launch PaNOSC badge, which will start up a MyBinder instance of the notebook I showed previously. From here, you can click any of these links to go to the respective page. Here you can see a notebook that reproduces figure 8. You can look through all of the code, see how the plot is produced, see what's loaded, and how the data is set up. Then we can look at the paper and see that the plots in the paper are identical to the ones in the notebook. Additionally, the paper also does some fitting. And as you can see here, it mentions that some slopes were fit to this scatter plot, and then finds the uncertainty values of some of the transmission and attenuation numbers. These are also worked out in the notebook as well, and you can see that these numbers match up to the ones mentioned in the paper. At the end, we also have the caption associated with this figure, again, just to clarify what's been done in the notebook. Cool. Thanks for listening.